Okay, encourage you to go back and watch my first video in this module if you haven't yet, where I introduced concepts like binary compound, subscript. I talk about how cations and ions or anions form ionic bonds. We're just going to work a little bit harder and step it up a notch in this video. This video is meant to be the second one, so if you haven't seen the first one in this module, I really want to encourage you to watch it. Okay. All right. In this one, we're going to show the difficulty, kind of the challenges, and how you have to do some basic math with positive and negatives. Okay. So we're going to take something from group 1. It can be anything, but we're going to take potassium. If you don't have a periodic table handy, you're going to want one. Before this unit's over, you're going to want to figure out a way to print one off or have one on your screen ready. I put that dot there because it's from group 1 and it's got that, that +1 cation state. Okay, and it's a metal, so it's going to be losing an electron. Now, let's say it bonds with phosphorus. Now, hopefully, you guys are able to go, okay, phosphorus, group 15. Okay, things in group 15 are going to be -3. Things in group 16 are going to be -2. They're going to take on 2 electrons. Things in group 17 are going to be -1. They're going to take on 1 electron. Group 15 means 1, 2, 3, 4, 5 electrons in the outermost shell. Okay, so in order to fill the rule of octet, how many of these little +1ers am I going to need? I've got 1 there. I'm going to need another one. And I'm going to need another one. Okay, then I can fill up that outermost shell and satisfy the rule of octet, which is 8 electrons in the outermost shell. So how would I write that? We know the name of it's going to be potassium phosphide. Potassium phosphide, because binary compounds, you change the last part, the suffix of the nonmetal to IDE. But the way you'd write that is using a subscript. Okay. Potassium phosphide would be K3P. 3 phosphorus, or 3 potassiums and 1 phosphorus. All right, let's do another one. This one's going to be interesting. Let's take something from group 2 and say something from group 1. Okay, so let's go with magnesium bromide. Magnesium bromide. I'd like you guys to make that before me. So would you pause that? Pause this as we take magnesium and bromine. Oops, I've been making it green just to make the non-metal different than the metal, the anion different than the cation. Okay, so here is bromine. It's in group 17. And here is magnesium. It's in group 2. It's a cation. Okay, so pause it and then show me how those would bond. How would you make a magnesium bromide? What would the ratios be there? Pause it and then answer the question. I'm going to give you the answer, but I want you to try it before I do. Okay, hopefully you paused it. Now we're going to do the answer. So first, let's what would it look like with its electron dot model? It's going to have 2, right? Because it's in group 2. Bromine is in group 17, so it's going to have 1, 2, 3, 4, 5, 6, 7. It's lacking 1, right? Okay. Things in group 17 have 7. Okay, so how many magnesiums and how many bromines? Well, bromine's going to take this electron, and that's going to fill the rule of octet. But in order to satisfy the rule of octet, you're going to have another bromine. 1, 2, 3, 4, 5, 6, 7. So now you filled the rule of octet for everything. The outermost shell of this is 8, the outermost shell, all 8. So how would you write that down? 2 bromines and 1 magnesium. Where would you put the subscript to make magnesium bromide? That's a weird ionic bond. Okay, you would write it with Mg and Br2. Okay, now why didn't I put a 1 down here to show that there's just 1 Mg? We don't do that. It's implied. Okay, it's implied. You would look silly to any chemist if you put a 1 down here, and nobody wants to look silly. It's automatically 1. So magnesium bromide. Okay, we'll do a few more. We do 1 more on this video, and then we'll practice a little bit more. Okay, so I'm going to throw a challenge at you. I want you guys to answer it before I do. Show me what sodium iodide would look like. Sodium iodide. Okay, do that before I do it. So try to beat me on every step. Sodium iodide. Sodium from group 1, iodine from group 17. Ready, set, go. Pause it, and then do it. Okay, I'm going to go ahead and do it. Hopefully you guys are ahead of me. You've paused it. So I put 1, 2, 3, 4, 5, 6, 7 right here because it's in group 17. Okay, -1. And sodium's in group 1. It's going to take on that electron. So sodium iodide. Remember, normally it's called iodine, but in a bond, in a polyatomic, or in a binary compound, it's going to become sodium iodide. Changes the suffix. It should just be NaI if you did it right. You only need 1 sodium to fill the outer shell. Okay, so that one wasn't tricky at all. Now let's step it up a notch and let's do one that's a little more on the tricky side. Okay, let's do some barium nitride. Ooh, that's a challenge. Barium nitride. Barium's in group 2. Okay, it's right here. It's a cation, +2. Barium and nitrogen is over here in group 15. See if you can do it before I do it. Show me what barium nitride would look like. Barium and nitrogen. What would that look like? See if you can beat me to the punch. Okay, now I'm just going to cheat. Instead of drawing the electron dot models, I'm going to draw what's called the oxidation states, or the little charges. So I'm going to go Ba, which is a +2, and nitrogen, which is a -3. Okay, so how many of each would you need? Well, it has to be balanced. It has to be neutral. So how many -3s and how many +2s? Let me show you how to cheat to help answer that question. Okay. All right, you ready? So the 3 is going to drop down here as a subscript. The 2 is going to drop down here as a subscript. And you get barium nitride. Huh? And it works because 3 times 2 is 6, and 2 times -3 is -6. So it's neutral. +6, -6, it's neutral. Okay? All right. Barium nitride.